The US Pentagon has debuted its new stealth bomber, the B-21 Raider.
The Pentagon just unveiled the country's newest nuclear stealth bomber. This comes after years of secret development. The B-21 Raider is the first new American bomber aircraft built in more than 30 years.
The Pentagon has made its move. In an era when defense budgets are dissected line by line and every procurement choice reverberates across the globe, one number rises above the noise: $10 billion. It is not a study, not a feasibility plan, but a direct authorization. Money already in motion. Its destination is no ordinary program. It is the foundation of an effort to mass produce the most advanced strategic bomber ever conceived, the B-21 Raider. For decades, long-range stealth bombers have been rare jewels of American air power. Powerful but scarce, icons more than fleets. The B-2 Spirit, its predecessor, remains one of the most formidable aircraft on the planet, but only 21 were ever built. The lesson was clear: capability without scale leaves gaps that adversaries can exploit. The B-21 is designed to change that calculus, shifting from a symbol to a system, from exclusivity to reproducibility. The Pentagon's commitment signals more than technological ambition. It represents a pivot in strategy to create not a handful of prototypes for display, but an operational backbone of American deterrence. In 2027, as global rivalries sharpen and military planners confront the rise of China and the resurgence of Russia, the United States is not content to showcase innovation. It is preparing to field it at scale, with an industrial base calibrated for sustained production. This is why foreign analysts are watching so closely. For years, the pattern of American procurement has been predictable: soaring costs, endless delays, and programs that shrink under the weight of their own ambition. Yet the B-21's path looks different. Backed by digital design, fortified supply chains, and industrial upgrades across multiple states, the Raider is moving from secrecy to serial production with unprecedented discipline. The implications stretch far beyond America's borders. If successful, the B-21 will not simply extend US strike reach, it will redefine it. It will mean that stealth bombers are no longer a rare tool, but a routine capability. It will shift deterrence from symbolic to structural. And it will pose a new question for adversaries. How do you compete with a fleet that can be replenished as quickly as it can be deployed? Which leads to the central question: why now? Why in this moment is the Pentagon committing to speed, scale, and resilience, not in whispers, but in billions? The roots of industrial scale. To appreciate the significance of the $10 billion figure, some perspective is necessary. The B-21 builds on lessons learned from its predecessor, the B-2 Spirit, America's last operational stealth bomber. The B-2 remains a potent symbol in United States air power, but its legacy is tempered by its limited numbers. Only 21 were built, each requiring years of painstaking assembly and maintenance under stringent security. While an engineering triumph, the B-2 became a case study in the challenges of producing advanced capability at scale. Its high cost and complex support requirements meant that the fleet remained small and operationally stretched. The B-21's blueprint is intentionally different. From its inception, the program prioritized mass production and cost effectiveness. The design process, supply chain organization, and manufacturing philosophy were all tailored with scale in mind, incorporating commercial aviation best practices and leveraging new tools such as digital modeling. A digital twin approach means every component, weld, and wire is first simulated and refined in the digital realm. This virtual prototype stage allows for early detection of production or integration problems, streamlining subsequent manufacturing and minimizing surprises on the assembly line. Supply chains are digitally mapped and stress-tested, reducing the risk of the kind of delays or overruns that plagued past projects. When the $10 billion authorization commenced movement through the budgeting process, it signaled more than incremental investment. It reflected a wager on heightened throughput, standardized processes, and the ability to use quantity, reliable, repeatable, and affordable, as a strategic asset. The question before analysts, domestic and foreign, is straightforward. Would the B-21 maintain its promise of scalability and cost containment? Inside Palmdale, the transformation of assembly. Palmdale, California, once known for early aerospace pioneering and shadowy test flights, has undergone its own transformation. The B-2's lineage can be traced to this desert airfield, where earlier generations relied on skilled craftsmanship and adaptive management to assemble advanced airframes. The present-day facility, however, operates on new principles. The B-21 assembly environment is notable for its emphasis on automation and precision. Robotics and digital workflow have become core features, reducing human error, improving consistency, and making quality assurance a continual process. Augmented reality overlays, for example, help technicians adhere to extremely tight tolerances. Facility upgrades have been made specifically to enable repeatable, low observable manufacturing. Across the country, subcontractors feed components and modules into Palmdale's digital supply chain with traceability and rigor. This is where the $10 billion investment's impact is most apparent, not only in capability, but in capacity. The emphasis is not simply on speed, but on meeting quality benchmarks at scale. New facilities and expanded supplier networks have materialized across several states, providing modules and subsystems for final B-21 assembly. Each B-21 that emerges is the product of a manufacturing process designed for consistent, large-scale output, a marked contrast to the hand-built approach that characterized the B-2. This methodology allows greater flexibility if production needs to ramp up due to unforeseen circumstances, ensuring America's strategic bomber force is less vulnerable to supply disruptions or production bottlenecks. This raises a key question. What is the current pace of production, and how scalable is it if global conditions deteriorate? Tracking numbers, shadows, certainty, and the global signal. Officially, only 2 B-21 airframes have been publicly acknowledged. Images from Edwards and Palmdale provide rare glimpses, but official statements about force structure and build cadence remain purposefully ambiguous. This opacity is a long-standing feature of strategic programs. Precise numbers, timelines, and build rates are classified to maintain operational security and strategic uncertainty. Nonetheless, modern defense analysis leverages open-source information, industrial reporting, satellite imagery, and public information on contracts and supply chain expansion. Third-party estimates suggest production lines are active, with a growing number of airframes moving through various build stages. While claims that 30 to 40 B-21s are already in construction phases are speculative and not officially confirmed, the pace and scale of associated infrastructure investments point to a deliberate ramp-up in production activity. The $10 billion allocated is distributed across procurement, facility upgrades, supply chain development, and base modernization. The effect of this investment is visible in rising activity at key installation sites and within the defense industrial base. As Air Force construction upgrades proceed at Ellsworth, Whiteman, and Dyess Air Force bases, the supporting infrastructure necessary for sustained B-21 operations takes shape. Hangars, maintenance shelters, and training centers. The pace and breadth of these preparations are indicative of intent to transition from experimental to operational scale. For foreign analysts who have viewed past American bomber programs as limited in scope, these developments demand renewed attention. The weight of the digital revolution. If there is a defining attribute of the B-21 program, it is the centrality of digitalization. The digital twin framework, by which each airframe is extensively modeled, tested, and validated in virtual space before manufacture, enables unprecedented efficiency in design, risk analysis, and upgrades. This enables each improvement to be rapidly propagated through the entire production line and shortens the feedback loop between operational experience and design modification. Maintenance and update cycles are streamlined, with digital tracking supporting robust logistics and inventory management. The intent is to avoid historical pitfalls, such as retrofitting fleets with delayed systems integration or losing time addressing preventable errors. Under this paradigm, reliability becomes an engineered feature of the process, not a byproduct of excess oversight or incremental patchwork. The B-21's maintainers and operators can leverage digital diagnostics, predictive maintenance algorithms, and unified documentation, all of which help ensure the aircraft remain mission-ready under operational tempo. This digital backbone supports both cost control and adaptability. It provides decision-makers with detailed visibility on production health, infrastructure status, and supply chain vulnerabilities. When production targets or configurations need to shift, the system can adjust rapidly, with minimal disruption compared to legacy lines. Ultimately, the B-21's digital framework is as much a signal of modernized military acquisition as the bomber's physical attributes. It reflects a broader trend within defense, leveraging information technology to reduce time to field, compress costs, and keep pace with adversaries who are increasingly adept at moving quickly in both technology and doctrine. Preparing the battlespace, infrastructure, training, and strategic readiness. No matter how advanced, a new bomber must be backed by infrastructure, personnel, and doctrine integration before it can affect real-world outcomes. The transition from prototype to operational asset requires coordinated efforts across basing, manpower, and support networks. Accordingly, major infrastructure investments are underway at key B-21 bases. Ellsworth Air Force Base in South Dakota, Whiteman in Missouri, and Dyess in Texas are each receiving substantial upgrades, ranging from hardened shelters for sensitive stealth coatings to state-of-the-art training facilities. These hardened, climate-controlled environments are critical for protecting sensitive technology, maintaining fleet readiness, and providing secure spaces for both maintenance and mission preparation. Equally important are the new training facilities. Rather than relying only on legacy training pipelines, Air Force crews will use immersive simulation, digital mission rehearsal, and multi-domain coordination. These approaches prepare Raider crews not only to operate the aircraft, but to integrate it into evolving concepts of operation, including joint and allied tasks, electronic warfare, and hypersonic weapon employment. The Air Force's sustained investment in support infrastructure is matched by a doctrinal shift, readiness for not just peacetime operations, but for high-tempo contingencies in multiple theaters. Construction, procurement, and facility investments, totaling billions, are building the support foundation required for the B-21 fleet to be continuously operational, rapidly deployed, and sustainable over protracted campaigns. Nearly every line item in the $10 billion appropriated is linked to these priorities, underscoring the intent to deliver a force that is strategically relevant, flexible, and resilient. Comparisons and contrast, foreign response to U.S. scale. The international context is inseparable from the B-21 program's significance. Major powers are watching closely. China's H-20 program and Russia's PAKDA are nominally analogous projects, but differ substantially in status and near-term prospects. Chinese defense publications reference the H-20 frequently, with highly anticipated expectations for an indigenous long-range stealth bomber. However, no credible flight demonstration or serial production evidence has been published to date. Russian authorities have publicized plans for the PAKDA, but available information indicates enduring delays and funding constraints. The fundamental difference is not just technological, but industrial. Developing one or two advanced prototypes is challenging enough. Producing a mature fleet of next-generation bombers requires an industrial base and acquisition process of a different order. The B-21 program, with its $10 billion backing, is prioritizing the ability to transition from experimental to operational scale more rapidly than foreign competitors have yet demonstrated. Strategic analysts in both Russia and China recognize that the bottleneck is not merely scientific innovation, but the consistent, large-scale production of modern air power. The United States, by reinvesting in its defense supply chain and production lines, is seeking to close the gap between next-generation technology and fielded capability. The difference is significant for global deterrence. It is not enough to possess a small number of operational prototypes. The ability to replenish, upgrade, and sustain a large fleet is what confers persistent strategic credibility. Mission evolution, multiplying roles for a modular force. Scalability within the B-21 program extends beyond simply numbers. The platform is being designed for adaptable mission roles. The digital foundation and modular systems architecture support a variety of payloads, allowing for responsive upgrades. While the primary mission of the B-21 remains long-range strike and deterrence, its open systems architecture supports ongoing adaptation. Potential mission sets, such as electronic warfare, intelligence collection, or network coordination, can be accommodated via hardware and software updates. This flexibility ensures the platform remains relevant in a rapidly changing threat environment. The modular design extends to weapons integration. As new ordnance types, potentially including hypersonic weapons, enter the inventory, the B-21 can be updated efficiently, using digital simulation and testing long before live integration or operational deployment. This reduces downtime and accelerates fielding of advanced capabilities. Such adaptability is not speculative, but aligned with current Air Force requirements for multi-mission potential. Persistent fleet updates using digitally validated upgrades enhance the platform's utility in evolving strategic contexts, such as denying access to contested areas or integrating with unmanned systems. In this way, fielding a fleet, dozens to potentially hundreds, of adaptable multi-mission bombers underpins America's intent to build not just a force for today's challenges, but one able to evolve as required by tomorrow's conflicts. Strategic implications, mass, deterrence, and the Indo-Pacific calculation. Military planners have long recognized that mass matters as much as technological edge. The B-21 program is driven by an objective to field no fewer than 100 airframes, with growing consensus that the required number will be higher to ensure simultaneous readiness in two major theaters. Defense analysts, including those at the Heritage Foundation and the Center for Strategic and Budgetary Assessments, have modeled likely requirements for long-range strike in the context of Pacific and European contingencies. The conclusion is clear. The strategic environment, marked by long distances, the need for operational flexibility, and advancing adversary capabilities, demands a larger fleet. The $10 billion invested in B-21 production, basing, and support directly reflects this reality. Sustaining a credible deterrent posture in the Indo-Pacific in particular, where adversary basing, anti-access systems, and time-distance calculations all challenge rapid response, requires persistent, deployable strike assets. The B-21 is integral to that calculus, augmenting the deterrent value of the existing bomber fleet while replacing older platforms as they retire. The scope of investment is not limited to aircraft and facilities. it supports workforce development, technology refresh cycles, and contingency planning. By fielding a sufficiently large and modern force, the United States aims to retain planning flexibility, hedge against future attrition or technical challenges, and keep pace with evolving strategic priorities. For now, neither the H-20 nor the PAKDA programs have demonstrated the capacity for sustained, high-cadence serial production. While both nations publicly aspire to field advanced bombers, available evidence points to ongoing challenges in moving beyond conceptual prototypes. Building toward a new paradigm. As the 2027 target for initial operational capability approaches, the trajectory of the B-21 program signals increased readiness. Facility construction, infrastructure upgrades, and supply chain activity continue to expand. Modernized training programs reflect the understanding that fielding new technology requires new skills and integrated approaches. Flight testing, likewise, is increasing in both frequency and complexity. While official program milestones are not publicized extensively, the cumulative evidence indicates a steady progression toward operational status. The Air Force's commitment is apparent in ongoing appropriations and incremental increases in production contracts, signifying confidence that previous acquisition obstacles are being addressed. Every procurement decision and associated industrial investment is intended to lay not just the physical groundwork for B-21 operations, but to ensure the United States force posture is sustainable and adaptive. The intention is clear: to put in place a production and support ecosystem that can expand or adjust as circumstances require, outpacing potential adversaries in fielded capability as well as in technological evolution. Foreign analysts studying American procurement signals recognize that the current era reflects a renewed emphasis on scale, readiness, and tempo, not simply headline innovation. The pattern is purposeful: steady, incremental expansion with an eye on long-term relevance, rather than one-off breakthroughs or symbolic milestones. As the $10 billion flows into factories, bases, and supporting infrastructure, the next chapter in American air power is being structured not as an episodic upgrade, but as a systemic shift, one that restores manufacturing discipline to the heart of strategic capability. This transformation is not taking place by chance. The evidence is in the expansion of the supply base, the modernization of construction and maintenance facilities, and the alignment of organizational incentives to ensure on-time, on-budget performance. The B-21's emergence is as much an industrial and organizational achievement as it is a product of aerospace engineering. The acknowledgement of the second B-21 airframe, disclosed as its presence became impossible to conceal, stands as a tangible reflection of program momentum, methodical process of force regeneration. What comes next is the continued shift from expectation to execution. The normalization of advanced capabilities, the closing of historical procurement gaps, and the systematic transition from novel prototypes to operational squadrons. For now, peer competitors' ambitions remain largely on the drawing board. The United States, through careful management, is positioned to return scalable, modern air power to the center of its deterrence strategy. In the current environment, the most significant actions are often those carried out persistently and without hype. The quiet funding of infrastructure, the expansion of production runs, and the relentless implementation of disciplined, digital-first workflows. As the B-21 program proceeds, the future of deterrence and readiness is shaped not by singular reveals or public demonstrations, but by the daily accumulation of productive activity, a methodical expansion of capability anchored in the reality of industrial repetition. At the heart of this process, the B-21 Raider is no longer an abstraction. It is becoming the backbone of the next generation of American air power, a replicated, reproducible, and supportable force ready for the evolving challenges ahead.